This DVD video presentation, prepared by Site-Specific Design, contains a brief discussion on the design assumptions which go into a low-pressure sewer system design. A coach once told me, for a team to be successful, it's like a puzzle. Each player having different potential, however, all must fit together to be successful. This analogy is true in a low-pressure sewer system. The advanced design features of the Environment-1 product could not stand on its own without the product's low maintenance requirements and the local service provided by Site-Specific Design. The final piece of the puzzle is the hydraulic analysis, which your engineer provides with the assistance of the E1 design team. It is this design which will provide the proper environment for the pumps and piping to ensure a successful installation. In 1969, a team of General Electric engineers pioneered the concept of the low-pressure sewer system. The result was the Environment-1 grinder pump. Today, with over 40 years of experience and well over 500,000 installations, E1 has gained the reputation of an extremely reliable, cost-effective pump and is at the heart of the world's leading low-pressure sewer systems. Between 1970 and 1971, the original and only pressure sewer demonstration was sponsored by the US EPA and conducted jointly by the engineers and scientists of the New York Department of Environmental Protection and the Environment-1 Corporation. Prototype E1 grinder pumps were operated in 12 residences in Albany, New York for a period of 13 months. The system was highly instrumentated, so the performance was monitored continuously. This work was reported in a comprehensive 1972 EPA report and many other documents which are still in publication today. From the Albany demonstration project, the simultaneous operation of what is also known as the probability method was derived and supported by the American Society of Civil Engineers as the preferred method of low-pressure sewer design. A key assumption in the probability design method is best illustrated in a table which compares the predicted maximum number of pumps running at once versus the number of pumps connected. The table shows the designer if 2 to 3 pumps are connected, the condition should be designed for 2 pumps operating simultaneously. If 19 to 30 cores are connected, then the design will call for 5 pumps operating. So, let's see how the probability design method applies to the Hideout community. The Hideout is a popular gated residential community in the Poconos, not far from Lake Wallenpaupack. Sprawling out over 4.5 square miles, there's approximately 2,800 single-family homes and 1,000 building lots in this 2,700-acre lake community. For the purpose of this discussion, we'll focus on the north section and Thornwood Terrace. The red lines represent the low-pressure sewer mains and laterals. On Thornwood, there's approximately 23 current or future connections. For example, the number of connections on Thornwood falls in the range of 19 to 30, so the design will call for the maximum number of pumps in simultaneous operation to be 5. Although at any given time during the day a single pump may be operating, the predicted probability that the maximum simultaneous operating pumps is 5. The first stage of the E1 preliminary design analysis, which is included in your package, contains the pipe sizing and branch analysis worksheet and the accumulated detention time calculation. Now let's take the drawing which illustrates the zone designation and see how it applies to the pipe sizing and branch analysis worksheet. At the engineer's request, we've selected SDR21 pipe and calculate the head loss with a C factor of 120. Default value of 200 gallons per day is used for each dwelling. Let's look at Zone 16. Zone 16 pumps into Zone 24. At the end of Zone 16, 21 pumps can be connected. As previously discussed, 5 pumps will be operating simultaneously. To calculate the maximum anticipated flow, we multiply the number of pumps by 11 and equals 55 gallons per minute. 3-inch pipe is selected since the flow velocity is greater than 2 feet per second. Accumulated friction loss is determined by adding the friction loss of each zone on the way to the final discharge point. The static head loss and elevations of the lowest pump is subtracted by the maximum elevation between the pump and the discharge point. Adding the values of friction loss and static loss, and the final column illustrates the maximum total dynamic head the pump will be experiencing. For zone 16, 96.2 feet is well below the progressive cavity's pump discharge rate of 185 feet. For the final stage in the low pressure sewer design, included in your package, we propose to utilize low pressure solution software. This software package, developed for the Environment 1 progressive cavity grinder pump by Kelly & Close Engineering, is based on the E1 design analysis and is empowered by AutoCAD Civil 3D. With the powerful flexibility in AutoCAD design document software, the authority can explore ideas more intuitively in 3D. Low Pressure Solution software package provides the ultimate in flexibility to customize your specific needs. For the final example, let's return to the north section in Thornwood Terrace. 2-foot contours are illustrated in red, laterals in white, and property lines in green. Many reports are available. We will look at the zone analysis worksheet. This provides the profile path for each zone. It gives us zone properties: length, number of pumps in the zone, pipe size, and velocity. The second column, maximum TDH, provides us a static head the pumps and zones will see. The third column investigates the total dynamic head that each pump will see. As important this document may be to the designer, it will be equally essential to the service provider. I'd like to thank you for taking the time to watch this DVD video presentation and considering the Environment 1 grinder pump for the Hideaway project. On behalf of Bob Moll of Environment 1 and Paul Tholey of Site Specific Design, I'm Kevin Callahan, and I'd like to thank you once again.